Welcome, folks. Today we're going to talk about standardization of access to Crash and Runtime Bulk Telemetry, and we'll define what we mean by this in a minute. But I think this is related to a lot of the discussions we've had yesterday and then even today, I think, from the introduction perspective. So first, let me introduce Karthik. He's my co-presenter today. And several people, of course, have worked on this, and we will get through that in a second. But the intent of this presentation primarily is from all the learnings we've had working with hyperscalers over the last few years, some of the specific challenges around the interfaces to access these systems at critical points is what's led us to this effort. So go ahead, Karthik. Okay, so the agenda today primarily is we'll define what bulk telemetry is, how it works today, and what our goals are. Go this way? Okay, perfect. There we go. I'll briefly talk about, or we'll briefly talk about platform monitoring technology, which is an Intel capability that gives you access to a lot of the large-scale telemetry within the system, within Intel systems, and it may be used at runtime or for a crash. And then we'll talk about why standardization of these in-band and out-of-band access mechanisms is essential for this work and work like this to actually see the fruits of its labor, right? And then we'll talk about the ideal standardized end state, and obviously, and call to action. Okay, so what are the goals? Wow, that color doesn't show up very well. Okay, what is bulk telemetry in general, right? It is essentially, as you may surmise, it's a really high volume of data, right? A very large number of metrics, as many as you can gather from a system, retrieved really quickly, synchronously, and as it says it within a single call, but with the fewest number of calls, right? The point is, when you're dealing with very large systems, very large scale systems, you want to be able to, especially crash is a really good example of this, right? So when a system crashes, the ability to reproduce the issue, debug and diagnose the issue, mitigate the issue, and recover from it as quickly as possible is essential when you're talking about scale systems where you cannot talk on time. So how do you do that if you're doing several serial calls to get all the data that you need to gain the kind of insight you need to solve the problem? You need to be able to get as much data as possible as quickly as possible. So that's one example. Also, the other aspect of it is as AI grows, right, and as data centers grow, they get more complex, we're introducing more components into the system as well. So there's interactions between these various components, and you need to have telemetry information from multiple components simultaneously to be able to make a useful decision on the system state and how to recover from it or even manage it. So those are the goals that drove, right? Okay, so where does it stand from a current state perspective, right? So, and what the problem statement is. The telemetry discovery, format, and consumption, right? So if you look at those three are very different. If you look at GPUs, CPUs, different vendors, et cetera, what is the telemetry you get? How do you interpret it? How do you analyze it? How do you use it is different, right? Environmental telemetry, and a lot of the discussions we've had over the last couple of days, especially from a redfish perspective, things like that, out-of-band telemetry tends to be, a lot of it tends to be environmental, right? And it tends to be go access a particular sensor, a particular point of information from a particular point in the system, and you're doing it not rapidly, right? You're doing it over periods of time. Performance telemetry, or in this case it says performance, but in general it's functional telemetry. It's about the function of the system, right? And you're trying to get insights out of that. You need a large, cache information, you need bandwidth information, you need hit counters, you need queue counters, things like that. Lots of information to maybe tune your applications, things like that. This tends to be typically in-band today, and it drives an application-centric view of the system. But when you look at cloud orchestration overall, a key requirement is to drive a consistent full system view, right? Both in-band and out-of-band. So you don't want to restrict certain types of information to one type of access mechanism. And you want to do this in a standard vendor-agnostic way to be able to use that information as consistently as possible across your various systems. So today there's no standard consumption model for this bulk telemetry. So the hardware path we've talked about, MCTP and PLDM becoming standards across the industry, and that definitely helps build the foundation for where this needs to go. But the extracting the data off the device itself and then analyzing it tends to have proprietary solutions from various companies. Of course, PMT is one example of it, or one portion of it. And then you have NVML, HLML, et cetera. And the telemetry implementations for this reason are not necessarily portable across these systems and vendor types. And then, of course, because these telemetry implementations are not portable, the analysis tools, et cetera, that you would use, et cetera, also tend to be proprietary, right? So what are the goals, right? So a goal today primarily is to make sure that we are standardizing these interfaces as much as we can. The goal should be, of course, there's going to be goodness from the telemetry perspective per vendor, right? So each device may generate and aggregate different telemetry, but how it's extracted off the device and then how it's used for the eventual cloud orchestration should be standardized as much as possible, right? Go ahead, and then I'll hand it off to Karthik.
Thank you. So in the next few slides, I'm going to talk a little bit about Intel PMT and what is it and how are we using that as an example for retrieving bulk telemetry as a solution from a consumption perspective, right? Like what Chinmay just mentioned. So at a high level, Intel PMT is one of our way of implementation of standard way of exposing telemetry and crash log through the host-based in-band methods and out-of-band methods, kind of agnostically across both these interfaces, right? And telemetry is collected and aggregated within the compute device, and it's retrieved equivalently across in-band and out-of-band. For example, crash logs provide debug state stored in warm reset persistent storage in the silicon can be retrieved on demand, which is one of the common use cases that you have seen. And for example, we also could look at some of the metrics such as core temperatures and memory bandwidth, C-state residencies, NIC utilizations, and network traffic, and all sort of components that are contributing to the system. To get a very high-level overview, we have published the XML in our Intel GitHub repo on PMT, where you can see the full list of XML of all the metrics that is available on our current generation Xeon 6 platform and the upcoming generations of products. So the next few minutes, I want to quickly touch upon what are the key models or key pillars that we look at within PMT. One is the data model itself, and where you have the telemetry semantic space and telemetry watchers have been configured. So essentially, the crash log is exposed to the MMIO data model, and which gives the ability to us to configure watchers. So watchers are essentially like you can, for example, you can use like a watcher for frequency, watcher for temperature, watcher for certain I/O bandwidth, or so you can define those configurations. So at a given point of a time, if my CPU crosses 60–80%, what should it trigger? What kind of alert should trigger, right? So watchers become a significant role. So you can configure n number of watchers for telemetry semantic space, which basically contribute to the semantic space. And that moves on to the next level, which is basically the discovery. So you have the discovery methods in two phases. One is the in-band method and the out-of-band method. So Chinmay touched upon using the BMC essentially to collect all the environmental telemetry today, which is coming out of the Redfish interface, right? And the in-band method essentially we use this the PMT discovery using the PMT driver and the DVSec on the PCIe interfaces. So you could have it's not just CPU only, but looking at the overall system. You're looking at GPUs, IPUs, XPUs, anything that you put onto the system itself as an overall end-to-end system. And it uses the standard MCTP interfaces. We're not defining any new interface here, which is using the existing interfaces. And the third stage is basically the transport. So you have the telemetry now, you have configured it, you have retrieved it, discovered it. Now you have to kind of consume it or transport it to the next level, right? For the system to consume, data visualization to consume it, right? So here we have two methods, basically the in-band and out-of-band transport, which uses the MMIO config space mapped into the container, the telemetry semantic space, and the Intel PECI commands, which gives us we are working with so many OEMs to define some of the commands, and which will help us to transport these telemetry into the final stage of metadata, where the XML and JSONs are published, and which can be kind of using collect-D, Telegraph, and some of the OpenBMC methods where we use for data visualization. So the next slide, I'll talk about later on the flows. We are talking about two different flows here. One is the in-band path and the out-of-band path, right? And I'll quickly zoom into each one of them. Primarily focusing on the in-band, what essentially happens is, let's say you have a workload running and you have defined certain amount of telemetry discoveries or watches there, and using the MMIO config space, these telemetry semantic space has been discovered and pumped onto the kernel space on the PMT driver. And that is then upstreamed into our, basically what we call as a telemetry file, which is mapped into each of these semantic TSSs have been mapped into each of these upper level files where you see the aggregated telemetry across the SOC. So it's coming from, as I told you, n number of watchers or n number of endpoints could all get aggregated into this telemetry file. And that is eventually pumped into this OpenTelemetry collector. So our friend here, Joko, who's our lead expert on telemetry on the software side, he's developed this PMT custom telemetry receiver, which basically consumes that telemetry which is coming on from the PMT, basically the PMT watcher, and going into this telemetry collector. The good part about this is one single telemetry collector which unifies both in-band and out-of-band, right? And which will help, that makes the life of the cloud service provider to consume this telemetry in a much easier way. And lastly, this is passed on using the OpenTelemetry framework into the observability framework and using tools like Prometheus and Grafana for visualization. And it can also be hooked up on all the, most of the CSPs environments today because all of them use OpenTelemetry as a kind of a plugin interface, right? With that, I will hand it back to Chinmay.
Thanks, Karthik. So Karthik mentioned two things, and to tie back to the earlier part, right? So I'll talk through two aspects here. We talked about equivalence between in-band and out-of-band, and we talked about the requirement to standardize, right? So now if you compare the picture that Karthik showed you from an in-band perspective to this one, again, you're getting the data off the device, in this case the CPU or this XPU, right, whatever you want to call it, out-of-band over MCTP, using your BMC in this case. But in the demo that Karthik alluded to, that Joko will have at the demo booth, at Intel demo booth, please visit that, today uses the PMT API, right? So this is now a vendor-specific way using MCTP to get that bulk telemetry data off of the platform. Now, we could standardize that, and today there's no bulk telemetry standard, but the DMTF body just described the file transfer protocol, and that would be ideal to extract this large amount of aggregated telemetry off of the SOC using PLDM. So you could instead use a standard path, PLDM over MCTP, to get that same data, right? And that could be vendor agnostic. That then feeds into a Redfish proxy, right? And we're using the log service schema in this case to extract it off platform, right? Before it goes into this, again, today there's an OpenTelemetry collector that is designed for the PMT specific receiver to access all of this data based off of the same similar semantic space that Karthik talked about. But the oval that you see here is identical between what was used in-band and what's used out-of-band, right? So that allows you to say, hey, we have a high reuse of components, and you're trying to rely as much as possible on standard interfaces while leaving the actual goodness of the telemetry, like how much telemetry to create, what telemetry to create, et cetera, to the vendors themselves. So now that you've seen this, and I encourage all of you to please go to the demo booth to see some of this in action and some of the challenges as well, what is the ideal end state, right? So we talked about, at the end of the day, the goal is to enable these, especially these hyperscale customers, to expose that data from whatever device they may be working with, discover it, and consume it in the way that they may need to manage their massive hyperscale systems, right? And so the off-platform standardization on the data model from OpenTelemetry would be ideal here. And basically, the intent would be to provide some sort of plug-and-play mechanism, consumption mechanism through Redfish and the OpenTelemetry collector framework. And on-platform, again, while PLDM today is focused on individual sensors, being able to extract large-scale telemetry to get a single snapshot view of the system, because in our experience, that is extremely valuable in a hyperscale context. being able to get that off of the platform in a single or as few calls as possible using the file transfer protocol would be ideal. So community engagement, trying to find the ideal standard and drive that would be greatly welcomed. And then I think that it would be ideal to continue this work in the cloud service model workstream. Yeah. So yeah, it's call to action. We talked about the problem to solve. The bulk telemetry landscape today doesn't really have the extraction and analysis standards that we need. And then we would propose this in the cloud service model workstream. PMT as a solution is available today with the Xeon 4 and of course with Xeon 6 as well. But yeah, the ideal end state would be some way to make sure that that stays scalable across vendors. And so please look through that information. Please visit the demo booth, and yeah, any questions, thank you.
We have a working demo in the Intel booth with Cassandra application running for the in-band side and obviously all the BMC interfaces exposing the out-of-band. So Joko's done a fantastic job of putting this together. So feel free to stop by in our in the booth and we can walk you through a demo, and happy to answer any questions and looking forward to further collaboration. Thank you, everyone.
We have time for questions.
Hey, Rob.
Hi. Hello? Hello?
Yep. Is that working?
There it goes. Okay.
Yeah.
So I'm Rob from Microsoft. You're talking here about the standardization of the interfaces. Have you also thought about standardization of the content, like what would be in your XML file?
Yeah, great question. So I think we briefly touched on this. The format of the content definitely would be good to standardize, right? I think so you need some sort of, people who've dealt with things that become architectural over several generations know that you need like enumeration and control type of concepts. So you could have a standard way to enumerate the various components of telemetry that you may expose. Certain vendors may expose richer telemetry and others may not, right? But at least you want to be able to enumerate and know exactly the same way that, hey, this is the telemetry that's available to us. And Karthik talked about this a little bit in the telemetric semantic space. That's the intent, right? So each independent telemetry component is an individual object, right? So standardization around how those objects are enumerated would also be welcomed, yes.
Jim from Oracle. We didn't quite get down to this level, but talking about standardization of the transport, the physical transport, USB versus I3C, and yesterday there was some talk about USB maybe as a universal transport, and across different vendors, this would be very important because, you know.
Yes.
So I wondered if you could talk to that.
Good question, and I'm sure Karthik will want to add as well. So again, yeah, we talked about the transport protocol upwards. The physical layer today, MCTP is compatible with, today many use the I3C interface. It's compatible with MCTP over PCIe. USB is another emerging standard here where MCTP would be compatible. So we don't necessarily need to mandate exactly the physical interface. As long as you're using PLDM over MCTP, it should be compatible. But yes, standardizing how that is extracted using a specific physical interface, I think would also benefit several system creators. So yes.
To answer your question, to add what Chinmay mentioned, we are definitely seeing the possible need for using USB, especially with AI systems and GPUs coming into the picture. We are seeing a huge amount of telemetry, which is kind of the bandwidth is getting limited just to export telemetry out. So I3C has its goodness and its limitations, but we are definitely looking at USB as a future product option as well. Yeah.
Yeah, and it's a good point that Karthik made to add, right? I mean, I3C for individual sensors, I2C, I3C for individual sensors makes a lot of sense. As you go to bandwidth, like higher bandwidth reasons, it's very hard. But then you have PCIe, which has its security implications, right? So then standardizing around USB as a point-to-point interconnect may be something that we want to go after.
When we say USB, what do we mean?
I'm not the transport expert, so we should take that.
Yeah, I think let's take this offline. Let's thank our speaker.